when you run regression on computer, it will not give you this nice looking equation. But it puts it in a table because computer wants to give you a lot of information. And in here, that's a short version of what you see in here. So here is a problem that I have in here. I want to know whether infant mortality of in different states. There are 50 states. I want to know whether infant mortality rate in states are affected by three variables. The level of poverty in a state, does it affect infant mortality? I want to know whether birth to unwed mothers affect infant mortality, and also percentage of white affects infant mortality. So I have three X's, correct? Percentage poverty, percentage birth to unwed mother, and percentage of white population in the state. I want to know whether these three affect infant mortality. Infant mortality rate is my dependent variable. That's infant mortality per 1,000 births. But anyway, and if you look at the top table, the very top table, you can identify where R squared is. The rest of them are for diagnostic purposes. So 51%. What that means is that 51% of the reason that there is infant mortality in this. So I went to 50 states for, let's say, 2016. I collected these four variables: infant mortality of the state, each state, and the other three independent variables. So that 51% R squared means that 51% of the reason for infant mortality has to do with these three things that I have included in my regression. The other 49% means some other, there are many other things out there that I didn't include them in here. Correct? There's some other reason that are there that causes infant, I'm sorry?
Oh, I'm sorry. That's adjusted? No, it's R squared.
R squared. Just look at R squared. Adjusted, forget about that. And these are all diagnostic, another diagnostic in here. Forget about the middle table. You see that F and then it is significant. That means that this R squared, that's one meaning of it is this.
Wait, it means
The
what?
second table,
What is the conservatism?
is which one?
The significant thing.
The second table, you have a significance for, it is a rather special ANOVA for you, and it is significant. That means that that R squared that you got, it is significant. You didn't get that R squared by chance.
If there's an ANOVA. If there's no ANOVA, then not
No,
significant.
it automatically will give you all these three tables by default. Whether you
You
like it
still
or
have
not,
the
it gives you
level.
these three tables.
Okay.
Now, if you go to the last table,
What were you saying about F? You started saying about the F in the second table.
are you talking to me?
Yeah.
What'd you say?
You started to say F on the second table and then you just stopped.
No, I said that the significance of F
Yeah.
determines whether your R squared is significant or not. So R squared 51% that you got, it is something real. It is not garbage. So forget about the second table, that's not important. The important thing is the third table. If you look at the column under B, those numbers are these coefficients right here. Those are these numbers. So for percentage poverty, so let me write it down in here so you probably can better visualize it. This is probably a better way to put it is in a table. So you have constant, which is the intercept. I have 11.012 plus 0.93, here is poverty, plus 0.086 x unwed mother, and negative 0.038 white, excuse me, percentage for white.
Is the poverty supposed to be 0.093?
Yeah,
Yes.
poverty is, so these numbers in the first column, if you were going to write the equation, we should never write the equation. It is very unusual to write this. But these numbers in the first column under B, unstandardized coefficients, are these numbers. So let's interpret them. So are you with me? I'm looking at column B.
Wait, how can we get into the next one?
Yeah, excuse me,
Oh, sorry.
X for 1. And then I need to put Alright. Okay. Forget about the constant. Has no meaning. Because when you are working in a two-dimensional, you can say the line intersects with what. But when you get to third, fourth dimensional thing, it's hard to forget about that. Coefficient for poverty, 0.093, this one. Go all the way across to under significance. Yeah. Go ahead.
Where did you get 0.82 on the R? Where is that?
This is from the last
Oh,
thing
okay,
that
okay.
for this one, the R square is 0.50.
Yeah, it was the same color, so I was like, where did you?
So what is this number? Actually, yeah, 0.0. 0.092. So what you want to do is that when you see this coefficient, go all the way across to the very last column, right column, and look at the significance of it.
So there's no relationship between these two?
It's not significant. We got 0.078. It's not significant. So what that means is that poverty has no impact on level of poverty among states has nothing to do with infant mortality. Had no impact. Don't do too much in this thing. I have fabricated all of these numbers. So on purpose, I wanted to come out with something. Let's move on to birth to unwed mothers. Is it significant?
Yeah.
So here it is. I put one asterisk over it so you can know that it's significant. So birth to unwed mother has impact on infant mortality. So what's the meaning of 0.086? That means that, remember, for unwed mother is a percentage. Is that as the percentage of birth to unwed mother increases by 1%, 1% birth to unwed mother goes up, then infant mortality goes up by 0.086. For each percent that birth to unwed mothers goes up, then infant mortality goes up by this much. Let's move on to the next one.
Dr. Jalal, can I ask you a quick question? So since poverty is not significant, you said we completely disregard the number in front of it, the 0.093?
So we're still doing that?
No, I didn't say that. I said that it shows us that poverty has no impact on infant mortality. I do not know what that is disregarded. No,
Okay.
this is a big finding. This is a really, really big finding.
Okay, so that, okay, so but just looking at the significant difference, we said
Yeah,
that
to
there's
see.
not-
That means that poverty has no impact on this.
Okay,
That doesn't mean that disregarded. That's a big finding.
okay.
So let's move on to percentage of population in a state. Is it significant? Very significant, huh? 0.001.
Mhm.
That means that for each extra percent in the population of white, as population of white goes up by 1%, infant mortality goes down, negative, goes down by this much.
Is that 0.03%? Is that?
Now, remember, infant mortality is measured by in 1,000. So it's not, infant mortality is not percent, it is infant mortality per 1,000, not per 100.
Do we always,
So, let's, if I'm going to talk about that, you know, it's going to confuse them.
Well, on the first one, you said as birth to unwed mother goes up by 1% and mortality.
Yeah, because
goes up
birth
by-
to unwed mother is percentage, but infant mortality is per 1,000 birth.
How do you know that?
So I'm going to actually give you the actual number, so I'm afraid to confuse you even more. Go ahead, Carlos.
do we always assume a 1% increase when we interpret the beta or the coefficient?
Not always. You need to look at how your independent variables are measured. Is it temperature? All of them, in this particular case, all of my independent variables were measured in percentage. It just happened that.
Yeah.
But
But if one of them is pound,
but
if
you're
for
gonna-
each pound that goes up, then
Uh-huh.
infant mortality goes down this one.
So it's an increment of 1.
So how would you word the white population again? When the white
Or for 1%, when white population goes up by 1%, remember, our independent variable for white is percentage. Then infant mortality goes down by 0.038 per 1,000 birth. Yes.
Okay, I'm just going back to the population. So since that wasn't significant, are we making any statement?
Population, you mean poverty?
Yeah, I'm sorry, poverty. Are we not making any statement about it?
Yeah.
You said it has no significance.
Poverty has no impact on infant mortality.
Do we do the percentage of it?
If it doesn't have any impact, the
There
case
we
is
go.
closed.
Okay, I'm just confused why it's still included, I guess.
Because we didn't know, when we wanted to do the research, we didn't know whether poverty has any impact or not. You didn't know ahead of time before running this regression.
Okay.
Perhaps that was one of your hypotheses, that you wanted to find out, does poverty have any impact on this or not? We found out, no, it doesn't. So ahead of time, you do not know any of these things.
So the point,
So, yeah, go ahead.
sorry, the 0.86 increase in infant mortality per 1,000. So we're saying that's 0.86 out of 1,000?
Yeah, and that's what,
Yeah. I'm with her.
is asked right in here. So, I'm afraid that I can confuse the rest of them asking the question. You can say it this way, you can say that for each percent that white population goes up, infant mortality goes down by 38 deaths per 1,000 birth.
You just create an inverse.
I multiply it by 1,000 everything. That makes more sense.
Can you say it one more time?
That as white population goes up by 1%, infant mortality goes down, by 38 deaths less in a million. Because it is 1 in 1,000, correct? If I multiply by 1,000, at 0.038, also multiply by 1,000, here I get 1 million, and here I get 38. So I'm afraid that that part will get confused right now, but you know what I'm talking about. You can say that for every 1 million birth, 38 extra people will die.
Yeah. 38, 38 don't die. Per,
Don't die.
per 1% increase in white
Yeah,
population.
do not die, because it goes down. But don't listen to me, because I know that then you get confused. But since the question came up, yes, go ahead.
Can you restate the one for unwed mother though? 'Cause that
For
one-
the unwed mother, for every percent birth to unwed mother, as percentage of birth to unwed mother goes up by 1%, remember I'm measuring it in terms of percentage. Infant mortality will go up by 86 more deaths per million. Or 0.086 per 1,000. Cannot have that this many kids. There is no such thing as this many kids. Multiply by
So we'd always multiply by 1,000, or I
Well,
mean,
in this particular case.
by the
it
number
is,
that
yeah,
they have.
Yeah, in this
Yeah.
case,
So if you're to write it down, you want it to be a tangible number, you don't wanna say 0.086 for
we
1,000.
don't say that because people do understand that
Okay,
for each extra percentage of birth to unwed mother, infant mortality will go up by this much. Of course, up in here you have mentioned that infant mortality is measured per 1,000 birth. So, but if you want to really be clear to your audience, the lay people, I would say for each percentage of white that goes up, we have 38 fewer deaths
per
per
one.
1 million.
Okay.
now for like I'm not good with percentages, so I don't know if it's something I should focus on as far as the final, like writing this down.
Yeah,
Will we get points taken off if we don't multiply in terms of percentage?
No, that year would be fine.
Okay.
I don't think,
So,
And is the standard error important?
diagnostic, one more that I'm not aware, oh, here it is.
Why do we look at unstandardized coefficients versus the standardized coefficient? We haven't gotten there yet?
I was going to get to that.
No.
You have 2 columns. One column called unstandardized. Let me explain it as we go along. You notice that in here, all of my variables, all 4 of these variables are continuous variables, ratio or interval, huh? I do not have any categorical variable in here. But I know that salary is influenced by, possibly influenced by gender, sex. There might be some prejudice, sex discrimination. Can I put sex in here? Can I put a categorical variable in here? Yes, in regression you can put a categorical variable, but there's a trick to it. The only type of, can I erase this? The only type of categorical variable that can go into regression is dummy variable.
Dummy?
Yep, dummy. Only dummy variables, if you have a categorical variable, it has to be in the form of dummy. What does that mean? A dummy variable, write that down. A dummy variable is a variable that can assume only 0 and 1.
Like, yeah, nothing.
You must code it as 0 and 1. You cannot code it 1 and 2, 3, or 4.
No.
So if you have sex in here, excuse me, if you have a variable called sex in here, you cannot type it 1, 2, 1, 2, 1, 2. Remember, I guess I mentioned at the beginning of the semester, get into the habit of using 0 and 1, not 1 and 2 or 3 and 4. So I put 0 for, let's say, male or female, doesn't matter. Let's say I use this for male and 1 for female. 0, 1, 0, 1, 1, 1, 1, 0, 0, 0. This is a dummy variable. Now I can put that into my regression. And that's fine.
Now, why can you only do 0 and 1 and not?
Mathematics, it has to do with mathematics. So if I put a sex in my regression, I get something like, for example, negative, let's say male I have put 0, 1 I have put female, okay? Let's suppose that is the case. It doesn't matter which one you do, male 1 or male 0, it's not going to make any difference. The only thing that you need to remember which one you coded 1. You need to know which you should know. So imagine, let's put it in here. You get plus, for example, 685 x sex. So you get this regression. We added one more variable. when you have a categorical variable, the meaning of this coefficient is different. This one means that the difference between male and female, the difference between the one that you coded 1 and 0, and this refers to that, the one that you coded 1. For example, here is female. Let's put that negative so I can make it complicated. It's negative. That means that women, because I have coded women as 1, correct? That means that women are making $685 less than, it's negative, less than men. If we remove the impact of, and that, Jordan might become clear, if we remove the impact of all other things, everything else, sex difference, this is sex discrimination. Removing the impact of years of education, I don't know, everything else. If we equalize, if you get a man and then get a woman, both of them same years of education, both of them the same age, both of them the same level of job satisfaction, both of them the same years of experience, then the man is making $685 more than the woman.
And you tell that by whoever's 1. So if male was 1, it would be a man makes
Yeah, if this was,
$685 less.
if you had put men 1,
So 1 is the variable technically.
most probably you would get a different sign in here. So you get men are making this much more than women. This is, so when you are dealing with a dummy, this coefficient means the difference between the one that you call it 0 and 1.
Okay. But 1 is always the one that you'll label the first one, I mean. Like,
It doesn't matter, yeah. You choose one of them. Go ahead, John.
When you're writing the equation like that, you always put your dummy variable at the very end,
No,
or
no,
the
no.
last word, or does it matter?
You don't write this equation anyway.
Okay.
You don't write it this way. So let me, so here is one that I have sex in there. So let's start interpreting the numbers in here. In here, I want to know whether the salary, the beginning salary of the clerical employees is affected by their years of experience, by their gender, by years of education, and age of the employees.
yes, it is.
So salary is my dependent variable, sex and the other ones are my independent variables. So let's look at the R squared. R squared is about 49%, huh? 0.489, first table. That means that the meaning of that 0.489 is that sex, education, age of the employee, years of experience, all of these 4 independent variables collectively explain about 49% of the reason why salaries are different. There are still 51% left that we did not include it in here. Obviously, the higher your R squared is, the better is your model, correct?
Yeah.
What is that? Is it R squared?
R squared is on the first table.
Yeah.
And the meaning of it, if you flip the page on C, for every one of them I have taken the note for you, so it is all there. The meaning of it is there. 49% of the variation in beginning salaries of the employees is due to the combined influence of independent variables in this model. Look, so let's move on to the last table under B. In here, let's see, except the last one, everything is significant. Sex is significant. Notice that look at it way, way up on the right side, female is coded 1. So here I have a coefficient of negative 1.525. Do you see that? It is significant. That means that the salary, there is a salary difference between male and female. And that women, this number refers to women because women is coded 1. Women are making $1,525 less than men if education, age, and experience are equalized. You get a man and a woman, the same education, same age, same years of experience, but woman is making about $1,500 less than men.
But how do you know it's that way instead of the male? How do you know that?
Under the model on the left-hand
Up
side,
there, I have put female equal to 1. Remember?
if you look at the table where it says model, left-hand side, there's a 1. That's how you know which one, which variable he's talking about.
Because female is coded 1.
Right.
So this number is referred to the one I have coded 1. Is less, that is a woman. This has to do with women. Because here women are.
And then because here.
No, that has nothing to do with it. Women, that means that for this it means nothing, that's extra clutter. This number that for sex refers to women,
Yeah, he's just using one.
because
Yeah.
women is
Yeah.
He's
coded
just using that number on the model or something.
So whichever one is coded, I still think
This
this.
coded 1 refers to that.
It's
And
just
then
the
women are
female
making
line.
this much
Okay.
less
Right,
because
but
negative,
So the
less
one
than men.
tells you,
What is it?
The table's already.
Because you know, she's saying
Yeah.
here that.
To the one that you have coded 1.
What's
Yes.
It's coded 1.
Okay.
Yeah, if it says 0, then it'd be
Okay,
right.
guys, on the sex, we know what sex was, correct?
Yes.
Right.
Sex. So that means that women are making, by the way, this one that is under model at the corner up in here has nothing, that has nothing to do with it.
It's just because.
Up, look at the very top row, very, 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 very top row to your right. It says male is equal to 1, female is equal to, excuse me, male equal to 0, female equal to 1. Do you see that in this corner? Female is coded 1 in these columns. Female is coded 1. So that means that these numbers under B for sex, we are referring to female. So women are making about $1,500 less than men.
Whichever one is.
If we remove the impact of all other things. So you can see that this is the pure discrimination. Controlling for age, experience, all
We're
other
better at
things.
everything else.
So let's move on to the years of education. It is significant, correct?
Yeah.
That means that for each extra year of education you have, your salary goes up by $650.55.
Wait, so this is basically saying because the female, I mean, $1,500 less.
Say it again.
Is that what that is basically saying?
I start from again, from the
Never mind,
beginning.
never mind.
Not only you're talking to yourself or me.
I don't know. Oh,
So
sorry.
we have moved now to education. Go ahead, Joe.
I'm so sorry, every time you call me, I forget my question. Oh, I do remember, okay. So you were talking about the measurements, like, you would say something goes up by 1 year or by something like that. So for educational level, would it be like bachelor's, master's, or would it be
No,
1 year?
I have measured education in terms of years. Look at up there, I have defined it. Educational level is
Oh,
the years of
okay, I did see
education.
that. So we'll always. go
Every
back-
variable I have defined them up there.
Okay.
Yeah.
Okay.
So for every year of education, for every extra year of education, a person's salary goes up by $650. I say it goes up because it's positive and also it's significant. If it were not significant, I would have said that education has no impact on salaries of people. Let's move on to the years of age of employee. Is it significant? Yes, it is. That means that for every year that you get older, your salary goes up by $33.02.
Now, there's no way to determine the difference between males like and females of each of those. Like education,
No,
yours,
no, you can't, I know what you
you have to.
mean. There are different ways to do it.
Wait, how goes up by how much?
For education, then, for which one, excuse me?
Or are you just doing age?
For age, that is that for every year an employee is older, for every extra year that an employee is older, his salary goes up by $33. $33.02. Matthew, you're very quiet. Are you following me?
Getting a little lost, but.
Why is it just, where does it say 1 year?
Up at the top.
So let's move on to work experience. Is measured work experience the years of experience at the time of hire?
No,
It is not significant. What does that mean? That means that your years of experience has no impact on your salary. Shall we define it one more time from the very beginning?
Wait, so I'm sorry, that one is, oh, cause it's,
Experience is not significant, correct?
no, I just realized that cause it's bigger than 25.
Morgan, what's the problem? The whole thing. So let's start with sex. It is significant, correct? Yes or no?
Yeah.
correct.
So sex affects the salaries of people. Have we established that?
Yes.
It's significant. And when you have a dummy variable, its coefficient is different than the way that you explain other coefficients. When you have a dummy variable, its coefficient means the difference between the one that you have coded 1 and coded 0. And the number you see in here refers to the one that you have coded 1. Which one have you coded 1, Morgan? Female. That means that women are making $1,525 less, because it's negative, less than men. So that $1,500, $1,525 is the difference between men and women. That's what it is. Are you?
Sorry, just zoning out. I get it, yeah.
So let's move on to the years of education. Years of education. Jenna, is the years of education significant? Go to the very right column, right across years of education level.
It'd be double star, right?
That means it's very, very significant, correct?
Yeah, how
So-
come there's no asterisk?
Can we make that?
Asterisk is when I put it in here.
So no, it won't be on there?
But I want it.
Put it on.
It helps me
Put
remember.
it here.
Like, I just didn't know, we should be looking for them on.
Yeah, that's what I'm like, wait, I need the asterisk.
Like on the phone.
The asterisks are not gonna possibly go on the table.
No, asterisks are not in here. You have the actual significance in the very right column.
Okay, I just assumed it was probably on
So, education is significant, correct? Is significant is 0.000, that means very, very significant. Education does impact salary. And remember, education is measured by years of education, correct?
Mhm.
That means that for every extra year of education a person has, his salary goes up because it's positive, $650. For every extra year of education, salary goes up by $650. Remember, all of these things I have defined them for you in here. If you flip the page, you will see them in here. How about age of the employee? Is that age significant?
Yes.
Mhm.
It is significant. So age of the employee has impact on salary. For every year that an employee gets older, his salary goes up by $33. Work experience is not significant, so work experience does not have impact on salary. So,
I have a quick question about
yes,
this one.
please.
So the constant, for their number, I know we use the 2665 when we're writing, like, if we're gonna write this, I know we use the other, but the significant level as far far as the constant, is that's
And
not.
Morphin regression in this particular has no meaning.
Remember all these stories I've been telling you?
Yes.
So you have the work experience is not like examples when you write out your equation, you use
Yeah, still yes. Because that is a finding itself.
because it's still a
Still, yeah, affects the numbers, and also it's a big finding. Could be that that was one of your hypotheses.
Can you explain beta coefficient?
I'm sorry?
Can you explain beta coefficient?
Yes.
For the category.
Let's look at one more, and then I want to explain what is beta is.
I wanna learn about betas.
I don't wanna learn anything new. We already gotta figure out all the issues, one exam, and then I can forget it for life.
Yeah.
We're gonna do a NOVA.
Like,
I feel like you can't learn.
Get it all. There's one question.
Here's a simple one, by the way. Here's a, probably I should have given you first.
Things circuit each other.
Here is a very, very simple one. Only two independent variables and number of words. I want to know whether the number of words of people are the number of words that they have. Remember we did something like that, independent detail. It's such a silly thing, but this one is becoming more complicated. I want to know whether there is a difference in the number of words that people have based on their sex and education. Two independent variables, sex and education, and number of words is my dependent variable. I'm sorry, Nora.
Is sex coded?
I'm sorry?
Yeah, it doesn't say
In
them.
here, let me see, which one I have coded, I didn't mention it in here. Let's say that, I made it
No,
very, I should
female
not.
slang.
Let's say that female is coded 1. Let's say, hold on a second. Yeah, let's say female is coded 1, male is coded 0. Okay, put that down in here. Female is coded 1, female is coded 1, male is 1.
And for
0.
the education, is it years of education?
That's years of education, yes. The first table on the top, what does this tell us? That means that years of education and sex collectively explain 64% of why there are differences in the number of words that people have. Education, definitely education has a lot to do with it. The R squared that you see, 0.64, that means that 64% of the variation in number of words that people have has to do with sex and education. Sex and education collectively explain 60% of the reason why there are differences in number of words that people have. Let's go down into the last table. We have sex in here, which is significant, correct? The significant is 0.003.
Yep.
I'm looking at the third table. Looking at sex, and it is significant, correct? That means sex has impact on number of words that people have. So I got 5,908. That's the number. That means that women, remember women are coded 1. Women have 5,908 words more than men if both of them have equal education. I'm controlling for the level of education. You get a man and you get a woman. Both of them have the same level of education. That woman has 5,908 words more than men. Because women is coded more.
And that number's only true if you're including the education in it too, like looking at the same education.
Yeah, that's if they have the same level of education. So in other words, the statistical term for is that if I control for education, that means that if both of them have the same level of education, woman still has 5,900 words more. So you realize that that t-test that we did at the beginning of semester was a silly thing to do. Because education was very important. So let's move on to education, the last line. Is education significant? Yes, 0.02, it is significant. So education does have impact on a number of words that people have. The more educated you are, the more words you have. And that means that for every year of education, for every extra year of education, you gain about 410 extra words.
Women, this is women? No,
What?
it's just in general.
Just in
In
general.
general.
Oh.
So if we remove the impact of sex, if sex is the, if you get two men, one is 1 year, has 1 extra year of education. This person has about 410 extra words. So if sex is the same, then 409 extra words is the difference.
So even though it's coded, I was confused. It's coded one is.
What is coded one?
That's only for when you're looking at the sex.
Right.
That was only.
Okay, never mind.
Got it.
Dr.
only
Fidel,
time
I
I've
wanted to
understood
know
anything
that,
in this class.
that the education level is the same, like, do we just know that, we just assume that?
Yeah, that is the whole, even when you're explaining sex,
No, how do we know the education level is the same?
What?
Are we just assuming that there's, yeah?
We're assuming that so we can just figure out the importance of that variable.
so when we look at the sex, that's what I want to ask. When you look at sex, we assume that educations are all the same for
Okay.
both sexes. When you look at the when you look at the education, you assume that the sexes are the same. In other words, that's probably a better way to understand. When you look at sex, you say if we remove the impact of education, what's the pure discrimination between men and women? If we remove the impact of education, what's the difference between men and women? But when you get to education, you say how much the number of words will go up for each extra year if sexes are, the impact of sex is removed.
You didn't interrupt me.
Oh, but that's what, yeah.
Interrupt,
Let's explain this one.
I love the one.
Just
Well, in my
think of it
notes,
this
I'm
way,
writing
how much
bright yellow
time
paper.
I have sat down to do
You
that?
guys up in Oregon, like, pass out.
Thank you. This is finals for my
With
students
all of
too.
these, you will get a feel for it. But I haven't answered the main question that, by the way, I forgot to answer your question. Let's look at that pink one again one more time. Yes. That's what we're looking at. Back to the pink
I
one.
very much want to
Back to
drink.
the people.
And I'll probably go home and have at least one.
Yeah.
Got it. Pink one.
Bless you. Bless you.
I like this one, good.
Back to the pink one.
Okay. So,
Column B are your coefficients. We call them coefficients. These are these numbers right here. Call them coefficients generically. And you notice that oftentimes these variables are measured differently. One of them is pound, one of them is dollar amount, one of them is years, one of them might be degrees, one of them might be gender, huh? All of these independent variables are different from each other in the unit of measurement. So when you look at column B and you explain it, that column B does not tell you which one has more impact, which one has less impact. correct? Because they are measured differently. One is in dollar amount, one is in pound. One of them is in degrees. So you cannot compare these numbers on their B and say, oh, this is a larger number, therefore has more impact, this one is smaller. No, one of them is in pound, one of them is in dollar, one of them is in degree of temperature, one of them is in percentages, one of them is sex, 0 and 1. So, because they are different unit of measurement are used in measuring different variables, you cannot compare them. What computer automatically will do for you is that it will get all of your independent variables, get all of these numbers right in here, and converts them to the same yardstick, measure them with the same yardstick. Think about it. Now, if you measure everything, pound, dollar amount, degrees, whatever, if you measure with the same yardstick, you will see it in column under beta. And now you can compare them. And then the one that is larger has more impact, the one that is smaller has less impact. So in this case of the pink one, if you look at it, we know that both sex and education are significant. Well, I mean, sex is 0, 1, education is years of education, two different units of measurement. So if you go to column beta, now you look at these numbers, you can see which one has more impact. Sex discrimination has more impact on people's, oh, this is words, number of words than education. Because it's larger number.
Can we tell by how much? Is it the difference?
No, it
between
just
the
tells
numbers?
you,
Which is bigger?
I'm going to confuse you.
Okay.
Because-
Take the second class, Carlos.
Oh,
Yeah.
boy.
Take the next class,
I
Carlos.
confuse you guys enough.
That's your
Might
limit.
as well
There you go.
just leave you with another confusion.
All right.
The yardstick that it is used is a standard deviation. Now let me put it in a layman's terms, simple English words. That 0.240. I want to explain in layman's simple words. That means that as the difference between men and women goes up by one standard deviation, women make 0.2 extra standard deviation. Clear like a mud, isn't it? How about education? For education means that for every extra standard deviation that education goes up, your number of words goes up by 0.100 standard deviation. Very simple. You never write it this way. You use that column beta only when you want to see which one has more impact, which one has less impact. So that's answer to Carla's.
So that's gonna be the alternate significance. The
I'm
higher-
sorry?
The higher the number in beta, the more impact, the lower the number in significance.
Provided it is significant. Of course, if it is not significant, the case is closed. Yeah, it has
Wait,
no
what did
impact.
you say? What did you say? What did you
Like inverse, like significance, the lower the number, like 0.005.
Inverse.
The more significance it has, but it's inverse for beta, the
Yeah.
higher the number.
Yeah.
Just look at the significance to see whether it has impact or not.
Yeah,
So
okay.
they're just.
So it speaks to significance, not to,
Yeah, a lot has to do. No, yeah,
It's just
it
a
does.
way to remember, like, significance, the lower, the more significance. Beta,
Shall we
higher
move
the
on
number.
to the orange one?
Yes.
To make sure that you guys are apparently confused, you do not read the top part. Let me explain that. We want to measure salary at the time of hire. That is my why. I want to know what impacts salaries of people. And look at up there what my independent variables are. Is the years of experience. Marriage or status is measured by married or not married. Okay? Married or not married. Degrees, whether you have college degree or no college degree. I have put them 0 and 1, the dummy. Age at the time of hire is 7 years. Okay, so I have two dummies in here, two variables that are continuous, experience and age. So if you look at the R squared is 0.76.
Wait, so the dummy variables are R cells
Are you talking to me? What did you say?
Which ones are the dummy variables?
Well, read this section. Look at me. Read this section.
Yeah, is it marginal status and degree?
Yeah.
Okay.
0, 1.
Okay. R squared is 70.76. That means that years of experience, marriage status, degree, and age, these four independent variables collectively explain 76% of why there are differences in salary. Still 25% left as unexplained. We do not know what else affects salary. So let's move down to the last table, the bottom table. Years of experience, is it significant?
Yes.
Yes. That means that for every extra year of experience an employee has, his salary goes up by $691. Marital status, does that have any impact on your salary? No. How about degree, does it have any impact? No. How about age?
Yes.
Yes. That means for each extra year that an employee is older, his salary goes up by $244.90.
Every year they're older.
For every year that they are older, salary goes up by $240. So which variable has more impact on salary, by the way?
Years.
Years of experience.
No, wait, marital status, no, yeah, years, I'm sorry, my eyes are wrong.
Years of education and years of experience, yes, 0.834. And then the second important variable that has impact,
The age.
age. The other two, obviously, the case is closed, they have no impact.
0.835 for years of experience, right? Yeah.
Did you ask him
Yeah.
if there was like a curve, like for example, if you talk about age and it increases every year, $244, but at like a certain point, could you show that?
Did we go over this one that has sex, education, age, and work experience? Did we have this one?
Yes, sir.
So it's like the.
We have 20 minutes left. Oh, that's 20 or 2?
I know everybody else will leave, I have
Don't even, for next.
Sometimes the issue is in class, I understand, when you teach, I get it, because you break it down in layman's terms for someone like me. But whenever I read like the homework assignments or tests, I feel like the way it's worded is kind of, it's tricky and misleading, and I get really confused and I doubt myself.
Not.
Yeah, and it confuses me. You guys have to stay
I
for
feel
this.
like for the take-home test that you sent out, when I read the first question or any of the questions, I don't know what the next step is, but like when I would answer even the homework or these, I know what the next step is, because it tells
Yeah,
you.
that might help you.
For this.
But not for the take-home test, that wouldn't help.
Maybe now after we've learned
Yeah,
this.
it is going to help you. Take a picture of this.
I don't
This will
know.
help.
But they're not, they're not like that on the test, though, they're paragraphs, or they're like
Well,
steps on what to do.
On the take-home test, it's really different than even like a word problem question like on the homework.
I'm just sorry that, Jane.
I just get confused.
I didn't know how to do number 2.
I didn't know how to even like read the take-home test barely, like I didn't know what it was
So
asking me to do.
why
at all.
did you want me to come here one day extra and hold office hours